Hi, hello everyone. This is a request video, and in this, there is a gentleman who has requested that if we can solve a prohibited transportation route problem by using least cost penalty method. Sorry. This is what not the penalty method, but the least cost method. So this is what I'm going to do. Though it doesn't make much, I would say, impact, but every particular query need to be resolved only in that spirit I'm making this video. So I'm going to use a lowest cost entry method. I am going to use a lowest cost entry method. However, the same problem I have already solved by using Vogel's approximation method, but the gentleman wanted to know about the lowest cost entry method. So this is the transportation problem. I have got three sources. I have got three warehouses here, and these are the cost of shipment. Two rupees, 2,200, 2 lakhs, whatever you want to consider, is the cost of shipping one unit from source S1 to warehouse W1, and so on. The table could be understand. This is a prohibited transportation route. That means if you are supplying something from S3 to W3, then it is infinite cost, or the shipment cannot reach here. Probably you are. This is entire shipment which is lost. So how many units are going to fall into this particular category? You can compare this solution with the solution which I have done by Vogel's approximation method, so that you can easily understand that what is the differentiation with two different solutions and how the cost actually comes out less in Vogel's approximation method. These are the demands. Oh, I have written it absolutely wrong. This is not demand. This is supply from the sources, and this is demand. So 20 units are demanded by warehouse W1, 15 units demanded by warehouse W2, and 30 units are demanded by warehouse W3. Why 10 units can be shipped from source S1, 15 units can be sourced from so can be shipped from source S2, or that's the production capacity, or this is the maximum capacity of shipment, and 40 units here. So if you sum it up, 40 plus 50 is 65, 40, 30 plus 20, 50 plus 15, 65. So the sum is 65, both sides, for the demand and for the supply. Since supply is equal to demand here, therefore it is a balanced transportation problem, and I can keep on solving this particular problem. If you want to check how to balance an unbalanced transportation problem, you can see another videos of mine. Let's start solving this problem. Let me find the lowest cost entry cost cell here. So there are two cells with lowest cost, one and one here. I can choose any of them. I choose this one. So I'm going to allocate minimum of demand and supply. So at W2 I have a demand of 15 units, and source S2 has a capacity to produce 15. So all 15 units I can allocate from source S2 to warehouse W2. So I can simply see that source S2 doesn't have anything more to send, and warehouse W2 doesn't have anything more to consume. So both these demand and supply are consumed. I'll go once again and search in the table for lowest cost, and here again I find the lowest cost here. In this case again can see that in this, for with respect to this cell, the lowest demand is 20 units, and sorry, not the lowest, but the demand is 20 units and the supply is 40 units. So I'm going to pick minimum of supply and demand. So I'm repeating it, supply is 40 units, demand is 20, so I'm going to enter a number 20 here. So the demand of market W1 is met, doesn't need anything else. So I am now going to search again for the lowest cost cell. This two is lowest, this two is lowest, this two is lowest. So I can make an allocation in this two, but I cannot. Why? Because W2's demand has already been satisfied. Here also I can, W1 demand has already been satisfied. Here also I cannot make any allocation because W2 demand is also satisfied. In this two, I cannot make an allocation once again because S2 doesn't have any unit to ship anywhere. So only cell left is this 3 right here. These are two threes. So M is the largest cost, infinite almost. These two threes. In this 3 again I cannot make an allocation. Why? Because all the demand of W2 has already been satisfied. So this is the only cell where I can allocate some units. So I can see S1 is capacity to supply 10 units here, while W3 has a capacity to consume 30 units, but I can only ship 10. So this source is also done. That means it has no more units to supply. While if you see, there is this cell is the only cell which is left now, some allocation can be met. And if you see, W3 is still required 20 units. So these 20 units actually go in the loss. So 20 plus 10, 30. It is also done. And if I'm going to calculate the transportation cost here, it is going to be 1 times 20 from this cell plus 1 times 15 from this cell plus 3 times 10, 3 per unit cost plus 10 units are shipped, and this is a lost shipment cost 20 times m. So you can see it is 20 plus 15 plus 30 plus 20 m, and how much it totals to 65 plus 20 m. So this is the cost of transportation. Thank you very much.